Thank you, Bob. Okay, so again, having gone through a set of sessions on how to do ISIS, we provided a set of test data that everyone could process, and hopefully with the idea that it would help you develop some questions and a sense of what it would take to produce a wavelength calibrated atmospheric response and instrument response corrected spectrum. And so now I've received some data from each of you that you've processed, and would you like to take a look at it? Okay. All right. Now, first, I might point out that David suggested something that would have been a better approach had I have taken this, but this was a few months ago that we kicked this off, and it kind of languished, and we're kind of coming back at it, having forgotten a lot of how we got here. Probably what would have been prudent, and I do have some data from some of you, would have been to compare the result that you get producing the instrument and atmospheric response corrected reference star, and then look at your response curve and see how those compare, and then compare the actual target spectrum. But data didn't come into me that way in any volume. Hi, Al. So let me start by working backwards, and I'm going to show you, I'm going to share my screen and show you all the spectra that I think I got on B690. Can everyone see my screen and the cursor?
Yep.
Okay. So I've got 7 people here responded and processed the data. And so this is all of them stacked in a pile. Where it says Woody, that's actually Bob's data in purple there. Plot Spectra is grabbing things out of the FITS header, and I didn't go edit the FITS headers to make them compare well, but I think that's the one Bob sent me. So you can see, obviously, there's some similarity that we all managed to get H alpha somewhere in the ballpark and H beta. We've got some potential things going on here, and obviously there's a couple of spectra of interest where there's something going on here. So what I want to do first is go back and look at these two right here. This is a plot. These are both my data. One of these was produced with 5.91 and the old database. So this is back when I processed this data on April 1st. The other one was processed with 5.9.6 and the latest version 8 of the ISIS database. And you can see, for all intents and purposes, they're identical, almost identical. So that was kind of encouraging, because at first I was afraid with 5.96 and the issues we went through with sort of 2 versions of 5.96 and 2 versions of the ISIS version 8 database, and the significant discrepancies there. I was concerned that what about all the data that I've done over the last several years? Was it still going to be okay in those other versions and compare favorably with 5.9.6? And I think this shows that it does. David, you did some testing on this also. Would you care to add something or comment?
Only that I think if you process in the same way with both versions, you will in the end get the same result. You'll get 2 response curves which look very different. But if you don't worry about that and you follow the usual procedure to smooth them and then use them to correct the reference and the target star, the end spectra are indistinguishable, as you found. Does that make sense?
It does to me. Any questions from the others?
Yeah, Woody, David, what exactly did Christian do? It looks like he just got an offset in flux. So if they were flux calibrated, I bet you'd be right on.
So I'm going to open 2 response curves. This is the response curve from the 5.9.1. And now I'm going to open the response curve produced in 5.96 when I process this data. See the notable difference?
Oh, yeah.
I mean,
So he's done a major blue side corrections.
yeah, and I think that the purpose, the intent he had was to improve his response for the UVEX in the blue end of the spectrum.
Mm-hmm.
So you can see obviously that you couldn't use an old response curve in the new software version. And this was really startling when I saw this this change. I mean, I was used to my response curves looking something like this, and then all of a sudden to have that go away and end up with a curve that looked like that, like, wow, something's really gone on here. But I think as you've seen from those two spectra that I just produced, where I processed all with the old or all with the new, as long as I did that response curve process the same as David described, then my results are, I think, comparable.
I wouldn't worry too much about the small difference in relative intensity of these two plots because of the final V694 Mon plots. I think that's almost within the noise of the methodology we're using in doing things like smoothing the response curve manually and such like.
So Woody, slide that slider down and let's take a closer look down at the 4,000 end or 3,800 and see the difference there.
Okay, well, there's 4,000. And again, this is the 5.9.1 in the old database and the old, basically method, not old method, but the old environment versus the new environment.
Mm.
And you wanted to look further. Obviously, it gets scarier out here because this is the harder part of that curve to, that continuum to smooth.
Yeah. The thing to remember when you look at these two curves is that ISIS adjusts the relative intensity of both of the curves to have the value of 1 at a wavelength you define on your settings page of ISIS. So if it was around 6,000, say 800 angstroms or whatever, you'll see down, you click the settings tab. Yeah, down in there. That defines the values as very small wavelength range, which ISIS uses to adjust the relative intensity of any output profile that it produces from this analysis. And in the case of the two that you were showing there for V694 Mon, you'll find that they align perfectly at that wavelength. What that means is that any small relative tilt, let's say, in the response curves of the two analyses is reflected with increasing size as you go to the left towards the blue end of the spectrum. So the mismatch gets worse at the blue end, and that's really a reflection of the rather, if you like, subjective way that we correct the response curve and smooth it. Again, not something to worry about terribly much, because I think with these sort of spectra that we produce, it's things like the wavelength of the emission and absorption lines is the thing that actually matters when somebody's coming along and analyzing the spectrum.
Mm-hmm.
It's less critical just exactly whether the level at the blue end is, 5% higher than it should be or 5% less.
Question about that spectral domain for profile scaling. One of the things, Woody, that I noticed when I was reducing this last night was you were using the, 6690 kind of pretty far into the red. I have habitually used a value that's sort of in the middle of V band, 5500 or thereabouts. David, what do you do?
I do very close to what Woody's done, simply because I picked that up from Christian Buell. That's the way he set up ISIS sort of by default. It has to be a region of the spectrum where there are not expected to be much structure. Not this in a generic sense, any spectrum of any star should be fairly flat within that wavelength range that you choose.
Makes sense.
Yeah, if there's a lot of structure in that region, obviously it then becomes a kind of stochastic process. So yeah, I think he's picked a wavelength range, quite a short wavelength range in that blue region where he knows there's unlikely to be much structure in the spectrum.
This is a slight shift to the red actually from the previous versions of ISIS, the default values.
Mm-hmm. Yeah, it got a bit complicated by the fact that the recalculated Miles library that came out at the same time as 5.9.6 was actually normalized to one at a slightly different wavelength. I never really got to understand why that happened. It was just a kind of observation that if you compared them, they were displaced vertically because of that. And that can sometimes cause you an issue when you do the compare between the spectrum you calculate and the one from the Miles library. It's just the checking process you do after the reference star, after you calculate the reference star spectrum. These sometimes you'll find they're parallel. They're not lined on top of each other because of that offset at the reference, at these lambda 1 to lambda 2 range points. Subtlety, but you might trip over it sometime.
Okay. Another thing I could do is to, let's go back and look at the individual response curves that I received this morning. And let's see. Oh. Okay, there's David's. And again, these are obviously smoothed response curves. What else did I get? Tony. Uh-oh.
Mm-hmm. Looking at that, one thing that comes to mind with Tony's one is whether this could be something to do with the wavelength calibration for the CCD chip. Whether
So,
you've
Tony,
got...
are you on the call?
Yeah. I think
Talk to me with a theory.
well, yeah, I know where it is because I've just corrected it. It's the camera pixel size.
Yes.
I didn't change it.
Ah,
right. Okay.
Okay.
I used my 4.42 instead of Woody's 6.45.
Yeah.
Okay, so it's interesting though to see that would be the impact if you had that off.
Yeah, it changes the dispersion equation for the calibration.
Yep. I had to do the same thing, Tony, because I've got a 694 camera, not the one that Woody has. So I realized I was going to have to correct that when I processed his data.
Bob, I thought you sent me a response file, but
I did, but I'm still using the old version of ISIS, so it'll be dramatically different from the ones you're showing.
All right, so it'll be what I kind of already showed with the two versions.
Yeah.
Okay. All right. Well, at least David's and mine seem to match reasonably tightly there. So let's go.
Tony, I'll bet when you look at the scroll of steps on the Go tab, it's probably objecting to you about wavelength calibration in there too. Huh?
Yeah, it did the first time.
Yeah, and
I just ignored it.
I had a question.
Shame.
I knew what I did.
I had a question from Tom, and I think a couple of days ago while I was traveling from Al, with ISIS objecting to one of the lines in the argon neon list file. I wonder if this is the explanation, the pixel size. Did you find an answer to that, Al or Tom?
Well, Woody, I changed the pixel size back to be exactly what you had. That started that way, but that still didn't give me the result. It still tells me that your initial calibration line is invalid in the file. Yet it shows up correct in the center of your list, and there's no additional characters or anything around it that would complicate it. So I don't quite understand what the problem is.
What do you do? Do you use a different pixel value from your actual pixel value?
I don't understand the question.
Right.
From the nominal one for the camera.
Yes, because.
Are you talking about in my list file?
No, when your pixel size is 6.45.
Oh, I see. I follow. I'm using the spec size.
Right. See, I can't do that because if I use the spec size for my 460, it doesn't work.
Okay, good to know. What did you use, David?
Yeah. I remember a post from Christian a long time ago saying you could just play with that number a little bit, move it up and down to improve the fit.
That's exactly what I did.
Yeah. I don't understand why a different value would work with some people and others, because I bet these chips are all identical.
Close.
Is that a different issue than the one about the list file that Woody provided us?
But yeah, my problem is I didn't know the 58 number that was supposed to be the pixel number, the X value. So Woody gave me 874. That got me a curve, but I was still having problems, and I think it's because my old 5.84, which is what I was using to match Woody's, was used for the Lears 3, and there's residual information rolling around in the background, because when I kept playing with numbers and changing things just to try and get it to give me the curve. And when it gave me a plot, it came out almost a straight line except for big sharp drops in the hydrogen beta line on the blue end, but from there on in it was a straight horizontal line. And then at that point I was able to go to the plot, and on the right side where it has the dispersion, it came up with all numbers that would have applied strictly to hydrogen alpha. So, there was like 65 something and 64, 90, whatever it was. But all those numbers in all of those columns were in the 6500. So something is putting it in there, even though it says use file list. It's not using your file list. And then when I actually copied yours into that dispersion where it lets you copy it in, it turned around and told me there were too many rows. And the too many rows is your 4 and your 2.583. Everything, they don't have a place. So I'm not sure. There's got to be something in the
Could be your chips too
from the Lears 3 hanging in there.
Yeah, it could be your CCD doesn't cover those lines. You don't record them because the chip's too small. Is that a possibility?
That's a 460.
Oh,
but I'm using his data, not mine.
Yeah. What CCD camera have you got?
Mine is the ATEC 460.
Yeah, I use the.
Okay, it's the same chip.
Yeah, Al's trying to rejigger his ISIS to do my data, and so he's obviously had to change settings he had for his camera to settings appropriate for my environment. And
Yeah.
that was obviously what I did, is just installed another instance of ISIS. Which seems to work. But so in this again, this file I'm showing you here is the file that you see here in file mode, Lisa Argon 15. And David originally helped me get started with this process because I was totally lost on how to use it. And so this first value is the polynomial fit. So fourth polynomial. And this number is not the camera spec scale. I had to actually experiment, and I don't remember all the experiments I went through, but this 2.583 is a number for my camera, and David would have a different number in his camera.
If you, sorry, I was just going to say, Woody, if you go to, I don't know if you can show this with your current version of ISIS is up on the screen, but if you go to the Go tab, does that show you the processing? Yeah. If you look at coefficient A1 at the bottom of that listing, that is the number that goes into that second line of the file, plus or minus maybe a little bit of adjustment. But
That's the nominal angstroms per pixel.
yeah, that's the nominal linear dispersion of your setup, ignoring the higher order variation. So that's the number that it uses that number to do an approximate calculation of where all the lines should be. When you go to the calibration tab, okay, can you do that? Yeah, and do a display on there. That line there, the bright line just to the left. Oh, sorry, you've given the wavelength of the line that you've got the cursor on. If you double click on that line, it fills in A equals box with the pixel count of that line. It then uses that linear dispersion to make an estimate of where all the other lines are in terms of X coordinate on the chip. And it then does the fit to those, to the nearest line it can find to each of those predicted. And if things are all working, it will pick up all of these lines correctly. If something is going wrong, it may be misidentifying or just missing one of those lines. And that throws the RMS value of the fit you see in the Go tab out. That can be a reason why you get a poor fit, because it just doesn't match up all these lines correctly. I mean, if that happens, one thing you can do is simply drop that line out of the list file. That won't cause any serious problems, but it does make you wonder why it didn't happen. And it could be, again, back to this parameter that Tony was talking about of the pixel size on the CCD. That also comes into that calculation, because it has to work out from the pixel size where the line, it uses the pixel size to calculate where all the lines are. Mm-hmm. I hope this is all making sense, but it's sort of the logic behind how Christian Buell does the wavelength calibration, given the position of just one line in that picture there.
Where Woody's got his cursor explains a problem that I had. The notes that Woody, that you had sent out, said 5944 was the right wavelength, but I assumed that referred to the bright line a little bit to the left of your cursor, which turns out to be 5852. Yeah. And that's what I used. I used the 5852 line and put that number into the wavelength thing, and it appeared to work just fine.
That's surprising.
Well, as long as you get the right line and the right wavelength, you'll extrapolate correctly.
If you put the right wavelength in and then click on that line, it should all work.
Yeah, it turns out if you put the wrong wavelength in and click on the wrong line, you get Abba Zaba.
Yep.
Not surprisingly.
Yeah, and I use this line here because that's the line David uses.
No, it's not.
Learned in my sleep.
I use the bright one. Would you?
That one?
Yep. I originally started using that faint one when I was working with Olivier Thiezy. and I just decided that the bright one looked like a stronger line and switched to using that one.
Oh man, you're breaking my system here.
But Woody, that brings up a question now. The only reason that we're having this issue is because you're telling it that there is a list file. If you don't have a list file, and if you do like David suggested with the double click on a line and then supply the value, is that the correct way to do it?
The correct way to do it is to identify the line you're going to use and double click, and it will write this number in here.
Yeah.
You can, of course, type into that field. Okay, it just accomplishes the same thing. So there's something I want to go back to here on this scale, this 2.583.
Yeah.
It has reminded me where I first got that. And I first got that from this coefficient. And you'll notice that's quite a difference, 2.58 and 2.54. I wonder what's changed in my environment since I came up with that several years ago. Something to pontificate on, because I'm puzzled by that.
Yeah, I think I only give that to 2 decimal places. I think that's enough. It doesn't have that. You don't need any more sensitivity than that.
Okay.
But that number changes. If you look at fits you do on different spectra, different stars, you find that number drifts around a little bit.
Yeah, well, clearly it has here.
Yeah.
If I remember right, the coefficient that shows up in the scroll on the Go tab is the coefficient related to the 4th order polynomial, but the one in the list file is a sort of best guess linear calibration angstroms per pixel, and they will be different because the one in the list file doesn't reflect the curvature of the true calibration curve. It's just used to find the lines.
I think it's a case of find they say the 2 decimal places in that number that gives you the best results. Play with them and see, just up them, down them, and see if where gives you the best fit, and then stick with that value.
Woody?
Yeah, and that will let you find all the lines you're interested in. I noted on my Alpi, the real calibration curve has a sufficient amount of curvature that you can't do a linear extrapolation and capture lines all the way from 3,800 to 7,000. There's too much curvature in the real curve.
Yep.
Woody, can you go to the profile?
Yeah, I will do that. But let me make one more comment on this. I experimented, as David has suggested, with and without this decimal point, with a 7, with an 8, with different third decimal points. And I would typically get abject failure in processing. And I actually narrowed in on this as something that hasn't failed me since then. And the kind of failure I'd get is I'd see an RMS error, not in the 0.07, but maybe 3 point something. And I would see that reflected in a R value of maybe 700 and something instead of 1,000. So there's a sensitivity to that value in the list file. And I got through this by experimentation. So it's interesting question. Okay, the profile tab.
All right, now hit the, what is it, dispersion tab to the right.
That looks like a dwarf novae.
What is that?
What you just saw was ice blown up.
What is that?
Huh? ISIS blew up. It just disappeared.
Woo.
All right.
So
That's a feature.
We'll restart it.
That's a new feature. Yeah.
It's a yellow vest. Woody, just a quick question, please.
Yes.
What camera are you using?
ATIC 414.
Okay, that's why it's got a 6.45 pixel.
Yeah, it's quite a bit larger pixel, and there's fewer of them.
Yeah, got you.
And
I think it's the same as the Starlight Express H9, isn't it?
Yes.
I mean,
Yeah.
I bought it because it was recommended at the time as a version of I think the ATIC 314.
Yeah.
Al, you wanted me to look at the profile tab. I've got to pull up I've got to establish some starting point here since I had to restart ISIS. Go to V694 Mon.
While you're pulling that up, David, if you're starting off with a brand new spectrograph, what
Yep.
number would you put in that list file? Just a general computation and start with that?
That spectrograph would come with a manual which tells you what the linear dispersion is for your spectrograph. Normally, that's just a design parameter.
Yeah, we're building these things and
Sorry?
I've not written the manual yet.
Right. Oh, well. Well, you've got a design parameter there, haven't you?
Yeah.
You're building it to a particular kind of linear dispersion.
Yeah.
That's the number I would start with, and then iterate from there. As Woody said, experiment
Okay.
to get a good fit.
Okay.
Jerry, to give you an idea, my camera pixel size is 4.54, but I have to use 4.42 in ISIS to make the dispersion and calibration work.
Ah,
Mhm.
got it.
Wow.
Okay, Al, I'm back to where I can attempt.
Okay, now hit the dispersion tab. All right, so you're seeing the same thing I'm seeing. That's what I have under on the left there, the line number 6382, 6402. That's the same thing I saw, and I thought that was what my problem was, but maybe not.
Well, see, I don't believe, and this is where this is what we're learning here, guys. I don't believe that I'm using anything on this page.
I agree with that, Woody. I never look at that page, and I think that is really that's page is to help you if you're trying to do your wavelength calibration using another method, not the .lst file method. You can manually put in wavelengths you want it to use for calibration in that method. I started doing that very early days and then moved on to the .list file. And since then, I've never used that particular window.
Yeah.
So that's kind of like the default window that you could fill out if you didn't use a list file?
Yeah, I guess so. I think it must be,
Got it.
yes.
Al, you use this? Is this?
Well, all right, what I did is I processed it the way I thought it should be processed. And it says use the list file. And then, like I said, I was getting weird results. So I finally got to the point where I got a profile and I went to the dispersion, and this is what I saw. And I said, so then I tried you can see there's a tab there to load a list file. So I tried to load your list file into it. It kicked that out because of the first two digits, the 4 and the 2 point, whatever it is, the dispersion equation.
Yes.
So at that point, I just kind of threw my hands up and said, you and I will have to have a discussion sometime, but I'm too busy.
Al, I've just looked at on my own system at the version of ISIS I was running earlier today, and when I look at that compute spectral dispersion screen, I get exactly the same numbers as you've got there.
Okay.
Certainly on the left-hand side for the wavelength, and on the right, I get a bunch of numbers which are pretty much the ones for the coefficients, polynomial coefficients, which were in Woody's Go file.
Okay.
listing.
So I've got another problem someplace. I just saw that and said, since I've been doing hydrogen alpha, it must be something that I generated or it generated, the system generated and stuck in there and was creating my problem. But obviously that's not my problem.
David, I'm really glad to hear that you ignore this compute spectral dispersion tab. Every time I've clicked on it, it has mystified me. You know, I'm specifying a fourth order polynomial and the button always says 3. And
I know. Best to ignore it.
got it.
I've written software for companies that time has evolved and you're afraid to take something out even though you've replaced it with another method because you're afraid of what'll break if you take it out and nobody uses it. That may be part of the case here. Al, so when you do your H-alpha processing, do you use this screen?
No,
Okay.
because I use the calibration line, so I just give it the 6504 or whatever it is, identify that, and it goes. So I don't know what it does after that.
I'll tell you what I'm going to do.
All I know is I get good results, so I don't touch anything.
I'm going to make this go away.
Mm-hmm.
Gone.
Gone.
Let me bring up another point that David pointed out to me. You'll notice when we were looking at our spectra here, when we look at mine here, I can find that other one that had all of them. This one. You'll notice that we've got different endpoints here. This is about 3,700 angstroms. This is about 3,900 angstroms. This is something, and again, we're all learning here, so I'll be embarrassed and just say what I'm thinking on this. But if you look at my line list here, David probably has one line in his higher wavelength than my 7067.
Yeah.
He's got a larger chip, and
Yep.
I can't get that one. I could probably tweak the internals of the spectrograph maybe and get that line, but I don't get that line. And then on the other end, 4158 is the lowest neon argon line that I've got in mine. And David pointed out, and we know this mathematically, is that interpolation is great between points, so between 7067, which is going to be out in here.
Yeah, but extrapolation won't work.
But extrapolation is a different thing. And so as you can see, I'm extrapolating beyond basically from here out is extrapolation, and from here to the red is extrapolation. And David, you truncated where, 3,800?
No, 3,900.
39.
I truncate all my spectra now that I process. I truncate at the blue end at 3,900 on the grounds that anything beyond that, even up to that, is a bit dubious. I noticed my wavelength calibration for that last Balmer line is usually not terribly accurate. The one just below 4,000. Can't remember, is that Epsilon? I'm not sure. I can't remember which one that is, but
Epsilon is 3,970.
yeah. If I look at when I compare with my reference star, when I compare the calculated versus the original Miles spectra for that line is usually not terribly well fitted.
Okay.
And then to the right of that, they get rapidly better. And I think that's just the effect that I'm extrapolating a fourth order polynomial beyond where it's defined. And I wouldn't expect it to be that accurate.
Okay.
And the same argument goes at the red end. If you look at the longest wavelength red line, you don't want to go too far beyond that because the same uncertainty is going to creep in. And I think I truncate it something like 7380. There's another reason I do that, and that's because the Miles, when I'm just trying to work out how this works. I know when I look at the Miles spectrum, I sometimes get a big spike in it, which I want to cut out. That may be just kind of the way I process. I don't know, but I don't know. Do you see that, Woody, when you do it?
Well, I can't get that high if you're referring to the red
Ah.
end.
No, okay, you
Well,
can't.
the miles spectrum for comparison runs from 3.7 up to 7.4. So it's pointless doing anything outside that.
Yeah,
I think that new fat Relco line bulb that I was telling you about allows you to identify the 3850 line.
uh-huh.
So it gives you some good blue lines. So
Right.
you can get below 4.1 with that Relco.
What about the other? What about the other end, Tony? How far does it go up in the red? I'm operating some areas at like 7779.
Oh, right, okay.
7779. Wow.
Yeah, it's an oxygen triplet up there that I was studying for CFID variable work a long time ago.
Uh-huh.
Right, just let me, where am I? Blue, 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 blue. I was looking at blue, I never bothered with red. It goes quite a way up there. Give me 2 ticks and I'll find out. I'll send you the calibration chart that I did for
Excellent.
that bulb at the blue and the red end. I had to
Thank
separate
you.
it. So yes, it does go quite. It gets up to way beyond 7. That's for sure.
Yeah.
So, question, David, again, to just embarrass myself, I have set the limits where I have, and let's say whatever it is, 3725 to 7280 or something,
Okay.
with the idea that I'm not throwing something away, and if someone is interested in looking at it, they can pursue it further. Do you think it's better to just crop it and throw it away?
That's a subjective judgment, I think.
Yeah.
What would be interesting to do, if you go to the full tab at the top right there and set that to 2.0 of the ISIS window, you know, the full, no, well, do it on the one that you were looking at, the reference star spectrum underneath that window, that one, yeah.
Oh, I'm sorry, this is just a screenshot.
Oh, right, it's not live.
No,
Okay.
I can get live if you want.
If you could bring up that live, I can show you the comment I was going to make.
Okay, so we want a reference star and it's,
Yeah,
okay,
you can bring up the reference star spectrum for that analysis, which is 41962,
yeah,
I think it was.
let me go find mine,
Well, yeah, okay.
that guy.
Yeah.
Okay, and now compare him.
And then drop on top of that the compare.
Okay, what was it, 41?
41692. That's it.
That guy there, okay.
Yep.
And let's do a compare.
Okay. So if you now stretch that, you know, the full tab at the top right.
I'm sorry, do what, David?
The button at the top right of that window that says full, not that one, the ISIS window itself. The button that says full.
Yeah, I'm sorry. Okay, yes.
Go to 2.0.
Okay.
And move that window out the road.
Yep.
And then you'll see that as your calibration goes more and more into the blue, it just drifts off.
So as an example here at, this would be hydrogen zeta.
Yeah.
This would be hydrogen.
Yeah, that's pretty good, that one. It's better than I get at that, on that line. That line tends to be not very good on when I process. So you're doing quite a good job there.
Okay. So actually what you've described then is a way sort of for me to make a better judgment on where I truncate or
Yeah.
crop.
You could crop that where that wavelength calibration starts to get a bit ropey.
Yeah, okay, so that could be here.
Mm-hmm.
This is not looking so good.
Mm. Your line resolution is not good there either. You know, the line profiles have just gone all screwy.
Yeah, and if you go a couple of more lines to the left, you reach a point where the blue curve is dipping down and the red curve is dipping up. So clearly the extrapolation has failed out there.
Well, here's another point to consider, is that maybe this is impacted by the difficulty in smoothing that continuum and creating a response curve.
Yeah. That's part of the problem, because you tend to get quite a lot of deep lines in that part of the response profile, because you're getting the Balmer lines that are just getting squashed together at that end of the spectrum on typical reference stars that we're using, A and B type stars, and you're having to try and estimate where the response profile runs through these big dips in the response profile you're calculating. So the whole thing becomes pretty unstable at that end of the spectrum.
So I think looking at this as a sample data, I would probably say 3850 might be a good number for my configuration.
Yeah.
Or a crop on the blue end and discard the rest of that, because I experience this every time I fit a response curve that David just described, is you're really taking a lot of guesses where to draw that, where to cut those spikes off to get that continuum.
Does it help to be able to zoom in that area?
Yeah, it does. And one of the things that I do in my processing, let me cancel this, is I go full screen. You know, ISIS kind of comes in a predefined size when you open it, but whenever I do the continuum fit, I go full screen. Sorry, it's my mother and brother that are on a road trip, but I'm going to hope it's not an emergency. If they call again, then I will step away. My mother's 86 and legally blind, but she's not driving.
You hope.
Fun City.
Yeah, I hope it's not her turn at the wheel. So,
Woody, are you able to select an area on that with the cursor in a box and zoom to it?
No, not with ISIS.
No, we're zoomed as much.
You have to do that in some other tool.
That's too bad.
Bob, you did quite a bit of work last night and wrote quite a long research paper on this. One of the things that you pointed out was the filter thing. I thought that'd be a great thing to discuss right now.
Sure. I can try to show an example, I think.
All right, let me unshare then.
Maybe. Let's see if I can remember how. Okay, do I push the share button?
Yes. And
ISIS. Share. Okay, you seeing that?
Mm-hmm.
Okay, so let me bring up. I think this is our reference star with no instrumental response function applied. The first thing I noticed, by the way, is when I opened the spectrum, it looked like this, and the trick was turn off automatic thresholding.
Mm-hmm.
There's let me zoom in. There was something weird going on down here way at the blue end. You get this artifact of in one case large negative numbers, and in the other case large positive numbers, and somewhere along the line the system divided by 0, and I didn't take the time to figure if it was in the flat or the dark or what. But, so my normal thing is, and I always see this in my Alpi spectra too, either at the blue end or the red end or both. And so my normal thing is I start off by cropping to get rid of that jumble of stuff, and then everything works fine. Yeah. So here's the raw measured spectrum of this guy. And so normally you would go to the response tab, select a reference spectrum. There's that's the star that we're using. Select it, and then say, do the response curve. And you see the thing down there in green, and you see all of those spikes. What I have always presumed is those spikes represent the fact that the resolution of the Miles spectrum is different from the resolution of the Lisa or the Alpi.
Yep.
And so if you filter the reference spectrum, I'll pick a number here, filter it by 3, and then ask for the response. All those spikes go away because now the two spectra are a lot more close in resolution, and so you say okay, and there's still a little of that spikiness there, but what it means is you can avoid a lot of that little nitty detail where you go into the continuum line and this over here at the red end, that atmospheric thing, you always end up bridging over that.
Yep.
But you can sort of ignore these others. And let's see, what I did last night, I think, was I used automatic 2 and something in the neighborhood of 60 or a little less. And you get a pretty decent fit. It bridges over those artifacts nicely. You can argue about what's going on down here. And when you say okay, you get a response curve that you kind of believe. And with my Alpi, I've fiddled around a lot to figure out what the magic number in the filter parameter is in that response function to make Miles and Alpi look really the same. And it simplifies the whole response calculation quite a bit.
Yeah. I do exactly the same thing, Bob. I found that filter is very useful for removing some of the more aggressive absorption or emission features in the line. If you go too far the other way, these features go from like emission to absorption. So there's a sweet spot in the middle for each, and it's different for each spectrum. Sometimes I use 3, sometimes 4, sometimes 5, but gives you the best fit.
Okay,
sorry, I was just going to say, when I'm smoothing, I never try and use the automatic 1 or 2. Neither of them work. As soon as you move the slider, you've gone up to the third option, which is the manual one.
Oh, I did not know that.
Yeah, I watched you doing it, and I thought, that ain't going to work, because if automatic 1 and 2 are just fixed solutions. You can't adjust them.
I'll be darned. Because I've always, I've clicked them and then started scrolling around until the fit works. I don't have to bother clicking on them, huh?
No. As soon as you start moving that slider, you've canceled the automatic options, and you're into manual mode.
Do you happen to know what these arrows do?
Yeah, if you bridge over a feature, a line, you just click to cancel it out. The left button allows you to go back.
Oh,
cancel the first.
What does the right button do?
Don't know.
I haven't figured that one out either. The left one works great. I think Al taught me that.
That's the undo button?
Yeah, it's the undo button. For
so
one,
the other one must be the
correction.
redo button.
Yeah.
The other must be redo.
It might well be. You can redo the undo.
Yes.
All right, can we back up for just 1 second?
Mm-hmm.
Bob, when you first put that spectrum up and you had that straight horizontal line, that's what I'm getting with Woody's. And you said you hit the automatic threshold, turned it off.
No, I cropped. Well, yeah, the automatic threshold turn off will do. Let me go back to that.
Yeah, it's a vertical scaling problem.
Yeah.
It's just distorting the profile.
All right, so
Profile's there, you just can't see it along that line because of this huge negative.
Yeah. Crop that at.
Okay, well, this is what I was seeing. So you turned off automatic threshold.
Yeah, first thing you do is turn off automatic threshold, and whatever number you have down here in the high and low level will show it. And you kind of, let me turn automatic threshold back on. You sort of know what it should be, because if you scroll around anywhere in this area that looks flat and follow the intensity that you're looking at, it's 1, 2, 3, 4, something in that neighborhood.
The data's all there.
Set an appropriate number down here in the high level, and then turn automatic thresholding off, and it'll be okay. But the real thing is, before you go any further, since there's clearly something honky there, just crop it out.
Yeah.
Use the crop button and pick the minimum and maximum wavelengths you want to look at, and then suddenly automatic thresholding works, and more importantly, all the arithmetic associated with instrumental response will work and not be dividing by 0 or anything like that.
Okay, so you turned the automatic threshold back on.
Yeah.
Okay.
Yeah, once you've gotten rid of those artifacts, everything's okay.
Okay.
So I do similar things, but I do them in the opposite order. When I get that spectrum with a big spike on it, I crop that spike out first. And if you do that, you don't have to switch off the automatic threshold.
Oh, that's a good idea.
That's the way I do it too.
Yeah.
And and I'm down here at 3,800 angstroms, which is about as blue as you're going to go anyhow.
Yeah.
When I've cropped it.
Another thing that I've seen on this screen that you've got up there, Bob, is sometimes my spectra will have a vertical blue line on that left border or on the right border.
Mm-hmm.
And if you don't crop it, when you try to fit a curve through it, it will drop down to chase that tail. So I sort of like crop that. I almost always crop a few angstroms on either end, because there's always some, as you point out, near divide by 0 thing, and it causes that curve that gets fitted through it to be wacko at both ends.
Yeah, I may not be remembering this right, but I think there are some of the Miles database spectra that don't go all the way into the blue or all the way into the red, and so you'll see a 0 sometimes in those guys.
Yeah, a lot of them have I find don't have some funny feature at 7,400 angstroms. And I always crop my spectrum at 7,380 for that reason.
Mm-hmm.
Get rid of that noise at the right hand end.
So one additional comment, Bob, you're using the old version of ISIS, or an old version. When you go to this new version of ISIS and you're working this response curve thing, all of that, the atmospheric features, the telluric features on the right, seem to have gone away as having to figure out how to bridge across those and jump those. Recall where you showed you make that line and you kind of jump.
Yeah.
They haven't gone away, Woody, but they're very suppressed.
Yeah, okay.
Yeah, I still bridge across them just to get rid of them.
That's actually sort of spooky. It means that somehow there's been an atmospheric response correction done in the new Miles database?
No, nothing like that. It's simply because there's such a large amplitude range now in the response profiles with the new version of ISIS, the vertical range is so large that part of the profile is just demagnified, if you like, to the point that you barely see these dips. They're still there, but they're very shallow.
Oh, they just look different.
They just look different.
On a percentage of continuum to dip, it'd be the same.
That's right. Because there's this huge spike at the blue end now with the new version of ISIS when you do a response correction.
Got it. I think that's, I don't remember if there were any other exciting things I learned.
So are we blessing the 9.56 or 5.96,
I'll stop sharing.
the newest version of ISIS?
I would suggest downloading that and starting to work with that from now on.
Okay.
But make sure you also download the version of the database on that same download screen so that everything is consistent.
They have to go together.
Yes.
Yeah, I think it's better. Actually, they don't have to go together, but that Miles database is improved because of the way it's calculated. Christian, I think this is a bit of an aside, but the Miles database has gone through a kind of de-reddening and reddening process to get it back to a spectrum that we measure as exoatmospheric. And the way it was originally done by Christian was not quite as good. So when he redid it for the latest version, he put in, I think, the best version he could get. There's been a bit of dialogue with Robin Ledbetter on the forum, you may have noticed if you were digging in that in the past. So the recommendation is to use the very latest version of the Miles library, and everything should then work out.
Yeah, and as we've mentioned in previous meetings, there were two versions of 5.96 software that came out about 3 weeks apart, and two versions of the database, version 8, that came out about 3 weeks apart. And as we've said before, if you go and do a fresh download of both, then you're assured of getting the latest versions, because there was a period in there where the mix match was not healthy.
Yeah, correct.
I'm going to share the screen here again, if I may. Go back to our results on V694 MON. And I think we've covered a lot of really good topics in terms of cropping the spectrum that accounts for some of these differences on the end. We've talked about the response curve fitting. We've talked about the use of the wavelength calibration file in our calib folder. But let's look a little bit at this right here. We all had the same data, and we've got quite a scattering on this hydrogen beta line. So, you know, we've talked about this here, and we've kind of got a better understanding for why that is. But why do we have this spread?
One possible reason could be the wavelength calibration solution. It looks like mine are more displaced to the red end than the average. If I'm reading this, I'm not sure which one's which.
I think you're this blue one here, David.
Okay. It may be, if mine's slightly to the red end, it could be because I had to change parameter values to process the data from your camera with my version of ISIS, and I didn't try and optimize the fit of things like pixel size and things like that. So I would ignore that one of mine in looking at how accurate that wavelength calibration is. I would probably want to have done a bit more work on that if I was trying to get that more accurate. If that, you understand what I'm saying?
Well, you're saying that you might tune that second row of the list file?
Oh, yeah.
And you might tune the size of your pixel size?
Possibly, because I just put in 6.45 and processed with that.
And 6.45 is what I'm using.
Right.
So again, we use the same data.
Sorry?
Well, I mean, we all had the same identical data set to work with.
That's right. The area where we could differ is in the way the wavelength calibration got applied. That's the only thing I can see as a possible area where that could have drifted a little bit between the two solutions. They should all be perfectly in alignment if we've all done it exactly correctly.
Yeah, and so that's obviously why I came back to this point here, is that we all attempted to do it correctly.
Yep.
What
There-
does
there-
alpha look like?
There might be a way to get a finer view on what we all did, since there's a calibration lamp line that's really close to this wavelength. If we were to look at the scroll in the Go tab,
Yep.
and say at that line at 4879, what was the delta lambda of our calibrations at that line?
Mm-hmm.
For what it's worth,
Yep.
the printout I have said that the calibration I did, delta lambda at that line was minus 0.065, which says it thinks it's did a pretty good job.
Yeah. I got minus 0.052.
Uh-huh.
An RMS of 0.054.
Yeah.
My ISIS blew up. Obviously, I had to restart it, and I lost everything in the Go tab. But one of the things I've pointed out before, I want to mention it again on this. I guess I need to pull up something here so we can look at it. Let's find.
Which line were you looking at, Bob?
You go in the when you hit the Go on the Go tab, there's this whole bunch of stuff that scrolls down.
Right. What wavelength?
If you look at, I was looking at wavelength 4879.864.
Yeah, I'm showing
11.
0.046.
Yeah, see, we're all in there at within a couple of hundredths of an angstrom.
Mm-hmm.
Hmm. Interesting.
There's a lot of reasons it won't work. Okay. Yeah, it's because I've changed the. There's an important point that I think it's an important point that I want to make again here. Okay, let's see if this will work now. Okay, so we go to this calibration thing here. I'm going to drag this slider across here where you can see it better. Center this up a little bit, and I'm going to display this guy right here. And there's my favorite line, which now I just this meeting that this has got to be my new favorite line. This guy right here. So I double click on this line, I get 860, I get 874. Double click again. Okay, there we are, 874. What I have found,
Yep.
when I go to run Go on this, is I might end up with an RMS of 3 point something and a really poor resolution. I come back here and I back that down by 1, 873, and then all of a sudden I get what I believe are good results with maybe a 0.05 RMS and a resolution of say 1,000.
Yep, I get exactly the same effect, Woody. It's all to do with the way ISIS tries to map from that one line onto the positions of all the other ones. And if you're just slightly off on that one, it throws the overall calibration off enough to give you a really bad result. And if you get that, just go back and move by 1 pixel and you'll find that things will just snap into a good fit usually.
So does that mean the finer the line you use, the better fit you get?
No, I don't think so. It's just the resolution. I mean, it's in single pixels, Depends how sensitive the whole system is in terms of your spectrograph to exactly what wavelength it needs to get to fit all the lines in the lamp spectrum. It's a sort of trial and error thing, that. But I saw exactly the effect that Woody said there. Just being 1 pixel off there can dramatically worsen the fit. And if you do get that, the quick thing to do is go back and just click 1 pixel to the right, and you'll probably find that it snaps back in.
No.
It's surprising that
David or left?
Doesn't, yeah, whatever.
For me, I always find it only works when I go to the left, but
Right.
maybe I need to experiment more.
I think that's,
it seems strange that Kristen didn't use some algorithm to centroid that line once you picked it.
yeah.
We're putting wavelengths into 3 decimal places, and we're putting pixels into 0 decimal places. And
Yep.
It's off considerably. Well, if it makes that much difference by 1 pixel, I would think you'd want to try and centroid that line rather than just saying it's this pixel or that pixel.
Mm-hmm. Yeah, you're probably right, Jerry. It's just the way he's done it.
Yeah.
There was description in one of the release notes a long time ago in ISIS that described a process that implied centroiding.
Mm-hmm.
Well, I think that's where we were talking about the pixel size and adjusting the pixel size from 6.45 to 6.44 or 6.43 or something like that. You reset the pixel size, and then it might jump back into place. I know I've played with that with the high res.
Mm-hmm.
Okay.
It's one reason I prefer to use the brighter line, is that I find it easier to center my the cursor in the middle of that line by eye. But that's just a subjective thing. I was also curious, the cursor you get is different from the one I see. You've now got a pointer on there.
Mm-hmm.
You had a cross before.
Yeah, I do. Now, I'm not sure. I'm not
My
sure.
my cross is like a negative of that. It's a white cross rather than a black cross with a white surround.
Interesting.
That's odd.
No, it doesn't
I see
make
this.
it good for
I see the
finding-
same thing.
Yeah, mine is a white cross also.
Right, mine is too.
Yeah.
I've got the French.
I don't do all that fancy color stuff.
I have the French version.
Yeah. Yeah. I don't have the color in the spectrum. I got rid of that. I unset that on the settings tab to get the whole thing as black and white.
Boring.
See what happens now.
Oh.
Yeah,
Oh, it's still the same.
but he's got the right kind of cursor.
Right.
Good point.
That makes it easier, I find, to center that on that line.
It's a
I just
fat
don't-
line.
My cursor changes colors. When I'm sitting on that line, the vertical side goes to black. So
Yeah.
so you can see it.
Well, all right. Have we? The purpose in the V694 Mon thing was to bring us together using one of our tools to try and get results that we have some confidence in when we share them with others. So have we gained some ground on that?
Yeah,
Yeah, I think so.
I think we've confused each other. Can I just before you wrap up, can I just share the screen with you, because you might be interested to see this. Can you see that plot?
Uh-huh.
Now we can.
Yeah. The red one is ISIS. The
Mhm.
blue one is Demetra.
Mm-hmm.
And the blue and when I process in 594, I get the blue type of curve. So I'm just wondering if they've changed after developing the Demetra software. They've changed their the way they do the response curves. Just a thought.
The blue is
Sorry.
Demetra?
Yeah. Blue's Demetra,
Yes.
and the red is the older version of ISIS. Is that right?
Yes.
Okay.
And they are the same star on the same night, same raw data, same comparison, virtually the same processing.
It would be interesting to see what the new version of ISIS would look like compared to Demetra. It might be very similar.
Yeah, that's what I was thinking. That's just what went through my head.
Yeah, I suspect in Demetra they've never used the trick that Christian Buell used in ISIS of multiplying the flat by the Planck curve.
Yeah. And yet it's the Alpi, so it's all Alpi data.
Mm-hmm. That's interesting.
Yep.
Hmm.
So
You
what
like Demetra, Tony?
I love it. Absolutely. Apart from the fact that I tried to demonstrate it to these guys and it crashed repeatedly like ISIS. it was a nightmare.
That's demo syndrome.
It is, absolutely. But it's very easy to use. It's very quick. And drawing the response curves, because there's more parameters in there, you can automatic parameters that you can vary.
Mm-hmm.
It's a dream. It gives you the same responses time and time again.
Yeah. We talked about making a version for other spectrographs, but it's never happened, I don't think.
Yes, there's another one out.
Mm-hmm.
And
Well, Ishel was going to be
the
second.
Ishel. Yeah, you're right, Woody. It's for the Ishel.
Uh-huh.
The Ishel in there.
Wow.
It's nice for visualization. It's a lot better than ISIS for visualizing what you're doing. Anyway.
Yeah. Interesting.
David, maybe in a couple of weeks we can bend on Christian and Francois and see if there's a Demetra version for Lisa.
Yeah. Maybe we should have a list of requested changes ready to.
Good thinking. So, okay, we're an hour and 20 minutes into this meeting. Anything else on B694 Mon or our effort to improve our ISIS and processing skills?
Well, I have a question for Tony. You got two different response curves. Did you process it all away to see if there was a difference in the end results?
They were exactly the same, and I submitted both to Bess.
Mm-hmm. And the results were the same?
Absolutely. Near on identical.
So there's something going on in the background in the process.
It really is strange. I mean, the reverse, they're obviously applying different weighting to the different way that the curves are applied. It just, they're doing it the other way around with much better, much more emphasis on the blue end.
Yeah.
Which given the UVEX might make sense.
That's exactly why Christian changed ISIS to the new version, so he could process his UVEX spectra better.
Hey, Woody.
Yes.
Are you open to a little email conversation a little later on this exact issue?
Sure.
Okay. I'm struggling. Okay. I just want to tell you that. So.
Okay.
Tom.
Yeah.
The calibration of the red end. I don't know if you can see this, but I've got lines up to 800.
Which bulb is that, Tony?
It's the big Relco, bulb. Now, I'm not saying it's going to be accurate, but I've easily up to 760.
Oh, okay.
So that's starting to get into the regime that you want.
Yeah.
Tom?
At what point does the second order spectrum come in?
Yeah, that's exactly. I know some of the lines that I've highlighted at the top end are second order.
Right.
Now I've seen this, I'm going to go back and put I don't have a cutoff filter. up at that top end.
Mm-hmm.
And this was on the Tragos
Mm-hmm.
to get
Oh.
the spread.
Mhm.
But yeah, I'll try and fit the second order to it because that really does come in above 800.
Mm-hmm. Okay. Sorry, Jerry, I cut across you.
I was just trying to make sure I knew the bulb. Tom, I have Tony sent me 3 of those fat Relcos, and if you'd like one to play with, I'll send it on.
Oh, excellent. I appreciate that. Yeah.
There's also been a bit of chat on the RS forum about bulbs for UV calibration. I don't know if you've been following that, if you're interested in that end of the spectrum.
Yeah,
Are they
we-
using xenon?
Yeah,
Are they using xenon,
I
David?
don't know. You'd have to go and have a look. I think it's, is it James Foster who's doing it?
Yeah,
Yeah, I sent them a link to it this morning, David.
Right, good.
they're reptile illumination bulbs to get your snakes and lizards into
That's right, yeah.
the UV.
Yeah. They're fine as long as you don't look at them.
Yeah, right. There's one that has UVA and UVB.
Wow.
Both
Nasty.
things.
All right, so are we done with V694 Mon then?
Yeah, thank you very much, Woody.
All right.
Has everybody noticed that bright dwarf nova in Cygnus at the moment? It's about 9th magnitude. You get super spectra from it.
Yeah, David, I had set up, I wanted to share the screen here on that, to show them your analysis, unless you've got a better way to do it there, if you don't mind.
Probably not. You go ahead. I've got 3 spectra already.
No, I was going to show them your data.
Yeah.
So, where did it go? I had it here.
Have you had any clear nights, David?
Yep. I've had about 3, 4 in a row. It's been about 25 degrees C down here every day. Too close to the Arctic Circle.
Too close to your hometown.
Why do you think I live down here?
Yeah.
Okay, I'm going to share this screen here, and I'll let David, as soon as I get this out of the way, let David describe this transient that he's talking about right here. Can you see that?
Yep.
Yeah.
Let's go to this one here.
Okay, that's the latest one I put up this morning. It's just fading away slowly, but lots of nice lines.
Can you full screen that image?
Let me see if I can.
Okay. That's good.
Yeah.
Good enough.
Okay.
Yep. These are flux calibrated, so the change is real. It's a measure of basically the reduction in flux in the accretion disk. What you're seeing there is basically a spectrum of an accretion disk plus some emission lines, because these things, when they're in outburst, the accretion disk drowns out the white dwarf. It certainly drowns out the secondary, which is usually several magnitudes fainter. So that's basically an accretion disk you're looking at with emission features plus some absorption. If you look at some of the Balmer lines, the emission is sitting on top of a broader absorption dip.
Yeah.
There's quite some subtle science going on there.
So one of the reasons I wanted to show this is that this was data I got on it, and it looks the same as David's, okay, or maybe not quite as good, but it looks the same.
Yeah, it's very similar.
Okay. But what I wanted to point out is this is not flux calibrated, and it's one night of data that I contributed.
Mm-hmm.
David here's where 2 nights, and then here's when he got his 3rd night, and the flux calibration really, to my mind, ramps up the amount of science that can be done with this data when you've got more than 1 night and when it's flux calibrated. And I think that's one of the things that many in our group really want to get into and develop a better understanding of what we're seeing in our spectra and what pounding on a target over time can do for us. And this is something that's changed very rapidly from what, David, 9.12 to 9.76 in 3 or 4 days. It's dim.
Mm-hmm. Yep. Calibration's done with a separately determined V magnitude. I have 2 scopes, and one's measuring actually B and V magnitudes of the star while I'm taking the spectrum, and I use the mean V magnitude over that period to flux calibrate the spectrum. I mean, it's basically the method I spoke about at the workshop.
Uh-huh.
So you actually use a separate scope.
Yes.
Yeah.
Yeah. But you could just as easily measure that magnitude at piggybacking on the scope that had the spectrograph.
Yeah.
You wouldn't need a big scope to measure 9th, 10th, 11th magnitude stars accurately enough.
As long as you do it at the same time.
Yeah. Yeah.
Yeah, and you're already pointed at the field, obviously.
That's right.
Yeah.
So this is what is going to be one of my major goals in the fall observing season here, is to get the refractor set up with a V-band filter on it. So that I can work out a methodology, a work practice for initiating V-band photometry data on this target, and then start my LISA spectrum collection data during that same, say, 45-minute time period.
Yeah.
Okay, I'll stop sharing. I had something from John Martin I want to share with you, so that where the screen share thing is here. I might have mentioned to a couple of you that John asked if he could join our group, and let's see, where is it? Well, anyway, he said, I want to join your group. Let me know if there's too many people who I gotta knock off so I can get in. That was a pretty good intro to the group.
Is he going to tell us we have to use IRAF?
Well, maybe not. He did mention PhD, so PhD as a guiding. So
yeah.
But anyway, he couldn't attend today's meeting as he had hoped because of the grade school planetarium thing. But we were talking in the previous meeting about solar observing, something to do here when we seem to have a lot of that and not much darkness. I'll just read you the little paragraph here. He said, to observe the sun, oh, wait a minute, what did he say? I had a comment on doing spectroscopy of the sun, which the group might like to have. To observe the sun as a point source, like a star, use a Jovian moon as a mirror. Ganymede or Europa work well. They are mostly water ice, which is very reflective. This is a professional approved approach. My PhD advisor did this to 0-point/calibrate all of his abundance measurements of Cepheid variables. Tip, set your PhD guide to guide on the moon, and it won't wander off the slit on a long exposure.
Mm-hmm. Yeah, I've guided on moons of Jupiter, and it works. Yeah, your spectrum is rather corrupted by large methane absorption bands. But, maybe not. It depends which moon, I guess, you look at. Yeah, maybe Io's worse.
Yeah, I mean, he said that these guys were water ice.
It's basically an ice ball, isn't it? Yeah. Yeah. No. Nice idea.
Of course, that requires dark skies to see the moon.
Oh, good point. Al, you want to just give us a quick update on your new mount setup?
It's beautiful. On cloudy nights, I picked up a AP 1100 that I got this week and just drove down to Sun City to see if it would fit in the observatory. and it fits, yay. But it looks like it had never been used. I can't find a scratch on it, not even a screw mark where the saddle was screwed onto the deck.
Wow.
So
Wow, nice.
I have,
Sounds like a good buy.
yes, it was a very good buy. And so now my AP 900 is going to go up to Nuns Park, which is northern Arizona in the high country, and get used about twice in the next 3 months. And there's about 3 days with no rain. You get a lot of rain up there, but
Yeah.
so I've ordered my observatory used the original 8-inch pier mounted on a 6-inch light pole to get up the 8 feet. So I had to order a new 8-inch pier from Astrophysics, so we can use it up north. And looking forward to it. It's beautiful.
And
Right.
what telescope goes on the 1100?
It'll be a C11. That's about all I'm going to be able to get on. And with the AP 900, I designed the roll-off roof to be able to accommodate the C14. But I don't gain enough on the high resolution to go to the C14. I think it's like a 0.1 or 0.2 mag is all I gain. So the C11 works real fine, and the AP, as Forrest will tell us there, Woody, is a beautiful looking piece of machinery. So certainly far superior to the 900.
Interesting. Okay, anybody else?
Sorry about the rain, guys.
Any
Especially
updates?
you, Tony.
Any updates? As you know, David and I will be at OHP 2019 here in a couple of weeks. Getting pretty excited about that.
Mm-hmm.
There's an opportunity. We might try to connect with the group just to do a shout out. I don't know what David, do you have any sense if there's Wi-Fi available up there or not?
It's a professional observatory. I guess it will have.
Yeah.
Yeah, it is. I'm sure I've used it when we were there
Okay.
before.
All right. Are you bringing a computer, by the way?
I'll bring a laptop. Will I? Yeah, I'll bring a laptop. Yeah.
I've been debating if I bring one or not.
Yeah.
I've got a lot of other weeks of dealing with it. It's just baggage I don't want to lose.
Yeah. I think I'll have to leave the spectrograph at home, though.
Yeah.
Well, you guys have fun.
Thank you.
Thank you.
Expect a full report when you get back, of course.
Of course. So the next meeting that we talked about last time would be early September, probably. I think September 3rd. I think we mentioned. So we'll have a summer break and see where we go from there. I had a lot of ideas from most of you, and some that are not here today in our last meeting of things they'd like to move into in the fall. And I've had some discussions with Bob and Jerry and Tony and David, and so we'll make a new plan in the fall. Anybody else want to kick in before we sign off here?
Just want to thank you for the video you did, Woody. That was very, very good.
Yeah.
Thank you. I think it would probably be useful in looking to helping people just starting out with ISIS to do one on setting up your ISIS screens, particularly the settings, masters, general, and calibration tabs. I think that'd be helpful to do a video on that also.
Boy, it sure helped me. I'm behind the curve behind you guys, so I'll catch up.